So the universe is absolutely huge. And to me, it's really amazing that we're able to look up from this tiny little planet and actually measure the distance to things which are so incredibly far away. Imagine yourself driving down along a road and looking out the window. Fences by the road seem to rush past really quickly. More distant trees seem to move more slowly, and distant mountains seem to barely move at all. This is due to something called parallax, and we can use it to measure distances. Say you wanted to know how far away a tree was. You could stop the car and take a picture of the tree with the mountain in the background. If you drove down the road and took another picture, you'd see the position of the tree shift relative to the mountain. If you knew how far you'd driven along the road, you could then do some simple maths to work out how far the tree was from you. This is how we measure the distance to the nearest stars. Instead of traveling down the road, we use the movement of the Earth as it orbits the Sun. In observations taken 6 months apart, the positions of nearby stars will shift relative to more distant stars in the background. And we can use the same geometry to work out how far away the nearby stars are from us. But the vast majority of things in space are much further away. Like the mountains in our example, they don't appear to move at all. So how do we know how far away they are? Imagine that you're walking around Greenwich Park at night, and you see a light. If the light moves away from you, you'll see it appear to get dimmer. And if it moves towards you, it will appear to get brighter. If you know exactly how luminous the light is, say it's a 40-watt bulb, you can use how bright it looks to you to work out its distance from you. And you can do the same for any other 40-watt bulbs. But other types of light could either be dim and up close, or bright and far away. Only objects of known luminosity, called standard candles, can be used to measure distances. There are lots of different things in the universe that we use as standard candles. For instance, Cepheid variable stars get brighter and dimmer in a regular way that tells us how luminous they are. So we can work out their distance, or the distance to a galaxy that they live in. But there are limits to using standard candles. What if something's in the way, blocking some of their light? Or what if you want to know the distance to a galaxy that has no standard candle? Imagine a fire engine. Its siren emits sound waves. As it rushes along the road, the crests of the sound waves in front of it are closer together than those behind it. Since the distance between the crests of sound waves determines pitch, the engine sounds higher as it approaches and deeper as it moves away. This is due to something called the Doppler effect, and it affects light waves emitted from moving sources too. Now shorter waves appear bluer, and longer waves appear redder. We can use this blue shift and red shift of light to study the motions of things in space. Looking at galaxies containing standard candles, astronomers found that the light from all distant galaxies was redshifted. The more distant the galaxy, the greater the redshift. We now understand this is because our universe is expanding. From our viewpoint, all distant galaxies seem to be moving away from us because the space between us and them is stretching out. More distant galaxies appear to recede faster because there's more space between us to expand. Light waves traveling to us from distant galaxies are redshifted, not because they're moving away from us, but because they've been stretched out as they traveled to us through our expanding universe. We know how far away things are in the distant universe by measuring how redshifted their light is. What's most incredible to me is how all these measurements build on each other. It's only by knowing the scale of our solar system, the distance between the Earth and the Sun, that we're able to measure the distances to nearby stars using parallax. If we can learn how far it is to some nearby standard candles using parallax, we can then use comparison between standard candles to measure the distances to farther stars and galaxies. Finally, by studying the motions of galaxies with standard candles, we learn we can use redshift to measure distances throughout our expanding universe.